Hey everybody, it's Rob Essler, and today I want to show you how to go from PD to audio plugin. And that's something you can do with the Pd4P3 library, and I'm going to show you how right now, and maybe this will change in the future. But for now, let's say you love working in PD, so you take a sketch like this, a sketch patch like this, which doesn't do much for simplicity's sake, but let's say this is a really cool patch that you want to convert to a plugin, right? So right now it's just a test tone. Well, you could go over to processing, and what I did was I just created an oscillator demo using the G4P controls library, which I installed using sketch import library add library, and I went to GUI and I found G4P, and that seemed, since it's got a 4 in the middle like my library, it seemed appropriate. So all I did was just create a couple of knobs and then basically make objects of them, and then I just set their values. This is not what you really need to know today, because you could figure this out probably yourself. But basically when you do that, you get this. Which does the same thing as here, right? Which, interestingly enough, forgot to set that to come out the audio. So we're going to close that. All right, so we know what we're trying to do. Let's close PD. So the point of this is to show you that you can more or less take your code here, that with some exceptions, but mainly the code that you put in your run algorithm, and it should work in an audio plugin like this here. So this is the same exact thing. And that is coming from the JUCE library. So first of all, let's just quickly talk about what's going on here. It's not that complicated. We have an oscillator, a frequency variable, and an amplitude variable. I have getters and setters. This should be get amp. Shame on me. So the getters and setters, right, get called here, and they're created here. So nothing that you haven't seen before, and then I free the memory there. Okay, so not all that complicated. So in JUCE, I created basically the same thing. I made a run algorithm with a few modifications based on, because this is C++ and we need to pass stereo values, and I'll talk about all about that in a second. But it's the exact same code. But I didn't use getters or setters, I just passed them in the run algorithm, because in this case I'm not using any audio input, so I decided to pass parameters to my run algorithm function instead of the input from the microphone. All right, so how do we do all this and make it work in JUCE? Okay, so the idea is that you have worked your algorithm in either PD and then tried it in processing, and it's working really well for you. You want to try to then convert it to a plugin. So we're actually going to close processing, and first thing you do is you get JUCE. Actually, it's called the Pro Juicer. That's on them, not me. So you download either education or personal. Obviously you don't need to purchase it to just try it. And it is open source, so you can get the source if you really prefer that. But if you start selling stuff, you need to get a license. Make sure you do that. Then you need to clone my library. And you said clone, what does that mean? Well, you can either just type this into a command line if you know how to use git, and if you don't know how to use git, you should be able to just hit clone here, or that's the only thing I know of. I think that's all you have to do. There are many ways you can get the code. So get PD++, put it in a folder. Okay, so now that you've done that, you should have the PD++ code. So remember, Pd4P3 stands for Pd++ for processing 3. Pd++ exists on its own, and it can be used in platforms like JUCE. So then you would go to the Pro Juicer, and you would create a new project. And you would create a basic plugin. And I think more or less that's all you need to know for now. You would change the project name if you didn't want it to be new project. And then it will open up this window, and it will say select your exporter. And if your Windows, it's only Visual Studio, but if your Mac will have Xcode, and I don't know what it does if it has Linux, if it even exists. So you just hit, basically create, and then it's going to create a new project, JUCE project, and it will have it under the build folder, a solution that you can open, and then it has 3 options to build. Oh, fine. All right, here we go. So it's going to show you, it has a Visual Studio project called Share Code. Shared code is basically everything that your different plugins will use. So then they have the standalone plugin and the VST3 plugin. So those you don't really have to do anything with, so you can close those, and you'll put everything in your shared code project. And it comes with an editor. So we're just going to open all these up because we're going to go back and forth. And the processor. So the editor is the window where you'd put all of your graphical interface, and your processor is where you put your audio. So think of it as like when you're working in processing, we have that processing, right? The sketch with all the draw function and all that. Think of that as your editor. And then the processor is your PD algorithm class, right? So basically whatever class you've created, that extended PD algorithm. And then that's kind of how we're going to think of it. Okay, so you can do one of two things. You could either just import the entire PD++ library, but that might be a little bit more than you need. So instead, we're just going to add the classes that we use. So I'm going to add, and it's going to be an existing item, and I downloaded PD++ into my documents. And you need some things just standard. So the first thing we're going to import is going to be PD master. And then if you're not familiar with C++, which you really right now don't have to be too familiar with it, but if you're not familiar with it at all, it instead of like in Java where the class is both defined and implemented in the same file, in C++, typically you have it defined in an H file and implemented in a C++ file. And it's, I'm not going to try to explain why that exists, but it does. All right, so that's the first thing we're going to add because everything uses PD master. And then we're going to add all of the different classes that we used from Pd4P3, which is just the oscillator. So we're definitely going to add that. And then you would get an error if you just stopped here, but you'd have to look at the code to know this error. So I'm telling you now, you're going to need also the unit generator.h because there are other classes that use the same functions. In PD, I decided just to put them into one and save some space, but definitely not confusion. So that wouldn't be the first time that things get confused in the world of coding. But it would just say, I can't find this file if you tried to build it, and then you just go and find it. Let's also tell it to look, right. Let's tell it to look for those files. It most likely doesn't know they are there. So we go to the project shared code, go to the project properties, and it gets this thing. This is kind of like in Xcode. It has that same kind of view. And in Xcode, it's basically the same thing. You're finding wherever it says additional include directories. And that's so that it knows where to look for your Pd++ code. So we're just going to go back to Pd++. Meh. And we're going to go here. We're going to add one more. Also, come on. Remember. I guess I could have just copied and pasted it, made it easier. All right, so those are the two folders we need to know. There's probably a way you could do it recursively. So you just go to the parent folder. I don't know how to do that in Visual Studio, nor do I care. So all we really need to know is that it needs to know that these exist. Okay, so now we can access, so we should be able to, in our processor, all right, we are going to add now new items to our folder. And just make sure you know where it's going and that you change the name. So we're going to, since for consistency's sake, we're going to just call it, we're going to make our own PD algorithm class. So it needs a CPP file and an H file. So we just got to make sure we put it in the same area as our source, just so it's in the right place. And that hopefully Visual Studio doesn't need to look for it. But if it can't find it, we will make it work. All right, open. And we're going to add the H file in the same spot, and it just needs to be called pdalgorithm.h. Okay, and so now I'm just going to straight up copy from my existing. And I'll just quickly talk through. All right, so it's not a lot there. We need to include PD master and oscillator.h. So in C++ land, import, right, is include. So we're just including this implementation file because we're inheriting PD master. And this is how you inherit in C++. See, it's very similar to Java with some small tweaks. And then we're using the oscillator. So we need to have the oscillator. And oscillator calls inside of it the unit generator. So we don't even need to do that. In fact, we probably don't need to import it into the project. Now that I'm thinking about it, it probably wouldn't have thrown an error because we were linking it directly to the Pd++ folder. So that's my fault if that is redundant, but it doesn't matter because it will still work. And then all we need to do is we're going to create a constructor, which is just called PD algorithm, and a deconstructor, which has got this little tilde next to it, which means this is called when the object is destroyed. Either the program is quit or something on the back end has said destroy, and that's where you put all your memory releases if you need them. But we won't need to do that here because we're not using the Java native interface that needs to allocate the memory dynamically. So we're just allocating the memory at runtime, so we don't need to destroy or free our memory. And then we're going to have our run algorithm. And I just gave it the values instead of creating getters and setters. But for now, let's actually create the getters and setters too. So just like we did in processing. So you need just the same exact syntax. And then we would have a double, nope, float get freak. And we could define that right here. But we could define all of them right in line. But let's not do that. Let's make it clear. And let's do the same thing for set amplitude. Float A. And get amplitude. Nope. Don't need to do anything. Okay, so these are how we basically, these are called prototypes. These basically say to look for these in our implementation. And then we're going to do two private variables. We're just going to do float freak and float amp, just like we did in Java. And now let's get some code in here. So this is our constructor, and inside of this you do anything that needs to happen in setup. So anything you need to set up here, so we could put like setup frequency default values. Okay, and then that looks better. And then we can create our getters and setters down here just for simplicity. One thing to keep in mind is that I'll talk about this buffer in a second. A buffer is something that is inherited from PD master, and it's just a way of passing more than one float at a time in and out of functions. So it's a little bit of a hack. In Java, you just use a class, and so it's a slight difference between Pd4P3 and this, but the idea is the same, is that you have two variables and left and right that you write your signal to, and you have two variables input that you'd write your signal to, and nothing else has changed. So for now, I'm not going to pass anything to run algorithm, and we have to change it here too. So the implementations have to match the declarations. All right, and then I'm gonna just straight up copy these, and then we'll clean them up. So you're always gonna need this naming structure. So this is telling the compiler what class this belongs to. So the double colon, right, says that PD algorithm has or get frequency or set frequency belongs to PD algorithm. So that if you had another class that might have had the same function, then there's no confusion as to who it belongs to, although that can actually cause confusion if you're not careful with your code. So we're just going to do it this way, and notice we don't have to do anything like synchronize. There's no locking on this because it's all done on the back end, so we don't have to worry about synchronization. As far as I know, JUCE should do all of that for you, which is the nice thing about using a library. So we're just going to set our frequency like we do in Java, and we're going to turn the frequency, and we are going to set our amplitude and return it. So you could just copy this straight from your Java, all this part, and you'd have to change you'd have to then put this in front of all of your functions. They're called functions in C and methods in Java. You'd have to create a constructor and deconstructor. This is your deconstructor here. And just this is where you would delete memory if you needed to. But we don't need to because, like I said, we're not actually allocating memory onto the heap. We're just putting it all in the stack, and it will be returned once the program closes. And then we just have to call get freak and set or get amp. And you could also put PD algorithm dot or colon get freak if you wanted to be litigious about it, but there's no other get freak that is going to be accessed, so we're just gonna put it there. Okay, so that's our algorithm. This is the buffer. So we just create a buffer, which we could just go straight to the declaration or definition in this case. So it's just called a structure in C or C++, and this is no different than a class, except that all the members are public. So I just now filled it with 4 floating point numbers that are eventually going to go to the audio hardware, and they have to be floats because most audio hardware is single position. And I just create 2 for input, 2 for output. That's it. So if you could create your own structure if you don't like that, but for now it exists. And then you would just put here, like we do in Java, it's just output L, output R. This is just the buffer dot output L, outbuff L, and outbuff R. So output buffer left, output buffer right. I just store it into a variable called signal, just because that's what I did on the C++ side to make it clear that this is signal numbers and everything is a signal. And then you just return the buffer, and that's all that you need to do. The getters and setters then we'll call in the JUCE side of things. All right, so the first thing we need to do is go to our plugin processor, and we need to include the PD algorithm. And the fact that it just saw it as a drop-down, that's good news. Okay, and then we're just going to create a new instance of that algorithm. One instance. Just call it PD. That's all we should have to do. And now on the processor side, this is kind of like our music class in processing. All of the audio gets pushed through this thing called process block into this thing called buffer. And that's really all you need to care about. We don't need this. Actually makes things more complicated. So instead we just make a loop, a for loop, and it has to be, find it. There it is. So we're just basically going to, where am I? We're just going to count the number of samples in the buffer. So it is buffer.get num samples I++. Like any for loop you've ever created. Why don't you like that? Oh yeah, because it's a function, not a variable. Okay, so this is actually a function that returns a number, not an actual variable, which big difference. So okay, so now we're good, and then all we have to do is make a new buffer here. Just call it buff, and we're just going to run our algorithm. Run algorithm. Okay. Now we're not done because all we've done is just stored it into a buffer. We've got to set the buffer, and in JUCE this just is buffer.set sample, and 0 is the left channel, I is the sample number, and then we give it the number we want to set it to, which is the output of our buffer. So buff.out buff L. So that sets the left channel. And then 1 is the right channel. Yeah, and we just want to set it to R. Even though this is mono, you might want to change it to stereo. All right, that's all we have to do for our DSP. We will have to update our variables using parameters. So we'll do that in a second. Let's run this and see what it does. It should just play a sine tone. I hope. Very nice. So now we successfully created a sine tone with JUCE using Pd++. Okay.